Hello everyone, welcome to Unacademy. Let's crack it. Guys, today in this video we are going to discuss the vector calculus part 3. In that vector calculus part 3, so we are going to discuss the previous year questions. The vector calculus, the previous year questions will be discussed from its basics, so you can get some tricks to crack the previous year questions, right? So before moving to the topic, actually tomorrow it's 11th July 11 a.m. It's a mega compact, right? I think you all are aware of it. India's largest weekly competition for GATE. Access your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators. Take it live to compete with the best, super fast and fun with the All India live leaderboard. Identify and improve your weak areas through the detailed video solutions. Use the code Moorthy536 for the tomorrow's Mega Compact. So you can get the benefits through the Mega Compact. So these are all the benefits. Yes, tomorrow in the month of July, the pool of 4 crore plus, right? So tomorrow 11th July 11 a.m. sharply the test Mega Compact will be started. 60 minutes 20 questions, and if you secure the rank from 1 to 3, then you can get the Unacademy complimentary subscription for 1 year. Rank 4 to 10 75% scholarship, rank 11 to 50 50% scholarship, rank 51 to 100 and 25% scholarship. 500 lucky participants will stand a chance to win a surprise gifts. Here it's coming to the point. It's Amazon gift vouchers, and 1000 rupees worth of the Amazon gift voucher you can win. It's one of the prize, and digital watch, iPad, or it may be an JBL headset. So these are all the benefits you are going to get tomorrow, right? Okay, so try to use the code Moorthy536 to attend the compact test, then you will get the benefits. Now the offer alert in this month for the GATE and ESE subscription, we are getting the offer. So what offer you are getting? Yes, it's a 12 plus 2 plus 3 or 24 plus 2 plus 4. So these are all the offers you are going to get in this month, right? And 2 months extra validity for the same GATE subscription, as well as 3 months competitive programming. Completely the competitive programming subscriptions will be given to you for the 24 months 2 years subscription. So you can get 4 months plus 6 months, 4 months plus 6 months competitive programming, right? So only you are paying 27,000 and you are getting the worth of 55,000, okay, subscription. And for the 2 years and get the value worth of 89k, right? 89,000. So here in the 1 year subscription you are saving 50% almost. Here almost would say 50. These are all the benefits you are getting. Use the code Moorthy536. Use the code Moorthy536. Use the code Moorthy536 to avail the benefits, to avail this offer. And if you use this code, so you can get the benefit, right? Okay. Then the one more scholarship test available tomorrow. It's a biggest week for you, right? For the participants, you can avail the many scholarships and crack Unacademy Master Scholarship test and win the prizes worth of 1.4 crores, right? So it's completely for the final year students. They enhance their programming skills. And 11 a.m. you are getting that test. So try to attend this test also by using the code. You can avail the benefit Moorthy536. Okay, so use the referral code and invite code Moorthy536 to avail the benefit. Is it clear now? Yes. So this is the batch course, right? Already the batch is started 16th June. Praveen Kulkarni sir, Devendra Singh Negi sir, Vehanathan sir, and myself. We 4 together handling the complete course for the mechanical engineering in English. Use the code Moorthy536 to avail the benefits as well as to join the batch. Now we are moving to the completely the vector calculus questions. Engineering mathematics, calculus, in the calculus chapter, it's second half, vector calculus. Very important for the mechanical, civil, electrical, electronics, and for the biomedical and chemical engineering and instrumentation. So now I am going to give you the previous question. So we have started the gradient. It's a first formula. Yesterday we have discussed in this previous video, part 1 and part 2. It's unit normal one. It's directional derivative. So coming to the directional derivative, it's a directional derivative, right? It's a formula for the directional derivative. Then it's an angle in between the two surfaces. It's an angle in between the two surfaces. So this is the formula for the angle in between the two surfaces, two normals, or it may be an angle in between the two tangents. Now the first question. So now I am going to give you the clarification on the previous question. It's mechanical engineering 2008 2-mark question. Directional derivative of the scalar point function at the point P in the direction. So here first we need to decide which one is direction, which one is given function. It's f of, yes, now take it as pi of. We have discussed the function with pi, right? So it's a f of x comma y comma z. So we can take its pi, right? It's pi of x comma y comma z. So if you want, you can keep it as f itself. It's x square plus 2y square plus z. Now we need to identify the del pi in order to identify the directional derivative. What about the del pi? I vector into dou pi divided by dou x plus j vector into dou pi divided by dou y plus k vector into dou pi divided by dou z. Dou pi divided by dou z, right? Now, so we need to identify the del pi, that is grade pi value. So grade pi, first differentiate the function with respect to x. And del pi is equal to the value of del pi. It's equal to it's 2x I vector with respect to y, 4y j vector with respect to z plus k vector. Now substitute the value. So the directional derivative at the point we need to identify it, and del pi of 1 comma 1 comma 2. So what will be the del pi of 1 comma 1 comma 2? So now the del pi of 1 comma 1 comma 2. So what about the value? It's 2i vector, right? 2i vector plus 4j vector plus k vector. It's a del pi, right? Now what will be the a vector? So here the a vector given in the question itself. Now identify the solution for the directional derivative. Directional derivative. Now directional derivative formula. The formula for the directional derivative, del pi dot a vector divided by its modulus of a vector. Del pi dot a vector divided by modulus of a vector. Is it clear now? Now substitute the del pi. Del pi is equal to 2i vector plus 4j vector plus k vector dot. What about the value of a vector here? So we need to identify the value of a vector. 2i plus 4j plus k vector. A vector is equal to 3i minus 4j. So we don't want to use the k vector here. 3i vector minus 4j vector divided by its root of 3 square plus minus 4 the whole square. Now the coefficient of I vector and I vector, it will be multiplied. If you multiply the I vector into I vector, it's 2 into 3 plus j vector into j vector, 4 into minus 4 plus k vector 1 into 0, which is whole divided by root of 9 plus, what will be the value here? It's equal to it's a 6 plus minus 16, 6 minus 16 divided by root of 25. It's equal to minus 10 divided by 5. Minus 10 divided by 5 is equal to, it's minus 2. Now the solution for this question is equal to minus 2. So minus 2 is the right answer for this given directional derivative. It's option B. Is it clear? Now let us, in case we are having any doubt. Good evening, Dansil. So while I am explaining the topics, in case you are having any doubts, immediately ping your doubt here. the directional derivative of the scalar function. Now the next question, the one more normal vector. Here the sphere surface they are giving, it's a surface, right? It's a surface. Unit outward normal vector at the point we need to identify. So what will be the formula for the unit outward normal vector? Unit normal vector to the given surface. Okay, unit normal to the vector I am giving it. Unit normal to the surface. It is given as n vector is equal to del pi divided by its modulus of del pi. So we require the value of del pi. So in order to identify the value of del pi, here the function they are giving. First identify the del pi, then substitute the point 1 divided by root 2, 1 divided by root 2 and 0. Yes, here unit normal vector function. So this is the formula. It's mechanical engineering 2012 1 mark question. Now I am giving it. The surface we can take it as its pi. We can take the pi of x comma y comma z is equal to its x square plus y square plus z square plus z square, right? Minus 1. Now the del pi, we know the formula for the del pi is equal to I vector into dou pi divided by dou x plus j vector into dou pi divided by dou y plus k vector into dou pi divided by dou z. Now the del pi, what about the value of del pi? Now the del pi is equal to, with respect to x, it's 2x I vector plus 2y j vector plus 2z k vector. Now substitute the point del pi of 1 divided by root 2 comma 1 divided by root 2 comma 0. And if you substitute the 2 divided by root 2, what about the value? It's 2 divided by root 2 I vector plus 2 divided by root 2 j vector, last one 0 plus 0 into k vector. 0 into k vector, it's equal to root 2 I vector plus root 2 j vector. Is it clear now? Yes or no? Del pi its magnitude. Yes, Ranjan, it's del pi is the magnitude, right? In the previous question. So coming to the unit normal vector, the unit normal vector formula. So coming to the unit normal vector, n vector is equal to del pi divided by modulus of del pi, its magnitude. So coming to the del pi, root 2 I vector plus root 2 j vector, it's a whole divided by root of root to the whole square plus root to the whole square. It's equal to what will be the value? Again root 2 I vector plus root 2 j vector, 2 plus 2, 2 plus 2 is equal to 4. Root of 2 is equal to, now the root 2 I vector plus root 2 j vector divided by 2. Now divided by 2. Yes sir, Srinivasa Perumal sir, yeah, it's right answer. Now coming to this question, so I am giving the value, listening, it's equal to, divided by 2, it's 1 divided by root 2 I vector plus 1 divided by root 2 j vector. It's an unit normal vector. Unit normal vector outweighs acting to the given surface. Is it clear now? So here the 1 divided by root 2 I vector plus 1 divided by root 2 the j vector, it's option A in the vector calculus part. It's option A is the right answer. The next one, yes, it's a GATE 2020 set to mechanical engineering 1 mark question. Again the directional derivative. So we need to identify the directional derivative. The directional derivative of f of x comma y comma z is equal to x y z at the given point. So the directional vector they are giving. So here we need to write the pi as well as a vector. here I am giving it. It's pi of x comma y comma z is equal to x y z. What about the value of a vector? Here a vector is equal to I vector minus 2j vector plus 2k vector. Is it clear now? It's mechanical engineering 2020 set to question. Now the directional derivative dd, I mentioned it as dd is equal to del pi dot a vector divided by modulus of a vector. What about the del pi? We are aware of the form already. It's I vector into dou pi divided by dou x plus j vector into it's dou pi divided by dou y plus k vector into. So now coming to the k vector. Now it's k vector into dou pi divided by dou z, right? So guys, I'm handling the complete engineering mathematics in the Unacademy Plus platform. It's common for all the department. So I'm explaining each and every concept from its basics, as well as I'm solving all the departments last 15 years previous year questions, GATE questions, right? So you will get the complete practice in the Plus platform. So try to take the subscription. Use the referral code Moorthy536 to avail the benefits. Okay, listen. Now what about the value of del pi? So here it's del pi is equal to, with respect to x, it's yz I vector, with respect to y, xz j vector, xy it's k vector, at the point minus 1 comma 1 comma 3. So we need to substitute del pi at the point minus 1 comma 1 comma 3, it's equal to, and if you substitute the value 1 into 3 into I vector plus x minus 1 into 3 into j vector plus k vector, it's xy minus 1 into 1, it's k vector, and if you consider the value, it's 3 I vector minus 3 j vector minus k vector, right? Now the directional derivative, it's direct question. What about the directional derivative here? Okay, fine. dd, directional derivative is equal to del pi, it's 3 I vector minus 3 j vector. Excuse me. It's 3 I vector minus 3 j vector minus k vector dot a vector I vector minus 2 j vector minus k vector. It's 3i, now dot I vector minus 2j vector plus 2k vector, it's a whole divided by root of 1 square plus 2 square plus 2 square. Now multiply the value. It's 3 into 1 is equal to 3. Minus 3 into plus 2, say minus 2, it's a plus 6, and it's minus 2. It's divided by root of 9, right? The solution is equal to, it's a 7 divided by 3. The 7 divided by 3 is the right answer. Is it clear now? Okay, it's right. Yes, it's option C, answer. Yeah, very good. Yes, it's option C is the right answer. Option C is the right answer. And now we are moving to the next question. Yes, it's a civil engineering 1994 question. Again the same kind of directional derivative. So these are the directional derivatives. So now you try. So you can try the same kind of procedure. So what we have used in this question, the same formula, same procedure. Now you try this problem. Parallelly I will give you the solution, right? The directional derivative of f of x comma y, guys. Every day, every weekday 6 p.m. I'm going to handle the YouTube live sessions for the engineering mathematics. coming Monday and Tuesday, 2 more sessions for vector calculus, followed by the complex variable will be discussed, right? And follow the Unacademy Acad YouTube channel every day 6 p.m. we are going to discuss the engineering mathematics, right? So it's a directional derivative of f of x comma y, right? F of x comma y comma z, not only the f of x and y. 2x square plus 3y square plus z square at the point 2 comma 1 comma 3 in the direction of the vector they are giving. Now we are going to identify the solution. Now coming to the pi of x comma y comma z is equal to, it's 2x square plus 3y square plus z square plus z square. Now you take the value del pi. So it's a direct one, we don't want to discuss too much, right? Del pi is equal to 4x I vector plus 6y j vector plus 2z k vector. Now substitute the particular point here. It's 2 comma 1 comma 3. Now del pi of 2 comma 1 comma 3, it's equal to 8 I vector, y is equal to 1 plus 6 j vector plus 6 k vector. Now what about the directional derivative? So coming to the directional derivative, it's equal to del pi dot a vector divided by modulus of a vector. Is it clear? Now the value del pi 8 I vector plus 6 j vector plus 6 k vector dot I am giving it, listen. Here a vector is equal to directional vector and minus 2k vector, it's divided by root of 1 square plus 2 square. Now multiply the value. If you multiply the value 8 into 1, 8. Now 6 into 0, 0 plus 0 minus 12 divided by its root of 5. It's equal to minus 4 divided by 5. Minus 4 divided by 5. 4 divided by root of 5. Yeah, fine. Yeah, it's root missing. Minus 4 divided by root 5. It's option B. Very good answer. Yes, minus 4 divided by root 5 is the right answer. Is it clear now? Okay, the one more question we are moving for the same directional derivative. So try to crack this question. Now, the scalar point function, the gradient of the point function. Here we need to identify the gradient, del pi value. So what will be the del pi for the given question? It's a civil engineering 2009 GATE question. 2009 GATE question. Now what will be the del pi? Gradient of pi. So we need to identify the gradient at the point. So the f of x comma y comma z, now we can take it as f. F, right? Del f we need to identify. Del f we need to identify. Therefore, I vector into dou f divided by dou x plus j vector into dou f divided by dou y plus k vector into dou f divided by dou z. So these are all the points, right? So these are all the points we need to identify. Now f with respect to x. What about the value of f with respect to x? It's 2x I vector. With respect to y, 6y j vector plus 4z k vector. Now substitute the point. The del pi at the point 1 comma 2 comma minus 1. So we need to substitute the point at 1 comma 2 comma minus 1. So this is the condition, right? Okay, fine. Now substitute 1, it's 2 I vector and 6 into 2 is equal to 12. 12 j vector minus 1 into 4 is equal to minus 4. Minus 4 k vector. 2 I vector plus 12 j vector minus 4 k vector. It's option B. Option B is the right answer for the directional derivative of the function, right? Yes. the one more question, directional derivative, civil engineering question. So try this question, you will get the benefit, right? You will get the practice. So the complete last 10 to 15 years previous year questions I am discussing in the Plus platform. Unacademy Plus, I am handling complete course on the engineering mathematics for GATE aspirants. So try to take the subscription using the code Moorthy536 to get the complete content in the Plus platform. Okay. So this is the referral code you have to use to join into the engineering mathematics class. Now, what will be the directional derivative? U of they are giving. So directional derivative, it's equal to del u dot a vector divided by modulus of a vector. First one we require the value for del u. What about the del u? Del u is equal to, first with respect to x, it's 2x I vector. Next one with respect to y, minus 3z j vector. Next one with respect to z, minus 3y k vector. At the point they are giving 2 comma minus 1 comma 4. Now del u at 2 comma minus 1 comma 4. 2 comma minus 1 comma 4. Is it clear now? Okay. It's 4 I vector minus of minus, it's a plus 3 j vector, and 4, oh sorry, z value we need to substitute, not x. Here it's z value we need to substitute, z. So z is equal to 4, it's minus 12 j vector, minus 3 into minus 1 plus 3 k vector. Now the directional derivative dd is equal to 4 I vector minus 12 j vector plus 3 k vector. Parallelly you give the solution for this question, dot I vector plus j vector minus 2 k vector divided by, it's root of 1 square plus 1 square plus minus 2 the whole square, Now multiply the value. 4 into 1 is equal to 4, minus 2 into plus 1, it's minus 12, plus 3 minus 2, it's minus 6, it's a whole divided by root of it's a 6, root of 6. And what will be the value here? Yes, it's minus 14 divided by root 6. So we have to give the solution in terms of the decimal points. So we need to give the solution in terms of decimal points. Now take the 14 divided by, it's minus 14 divided by root of 6. It's equal to minus 5.72. Minus 5.72. So this will be the solution for the given question. It's a directional derivative for the given question. It's a GATE 2015 set 1 2 mark question from the civil engineering. Very good answer. It's a minus 14. So thank you so much, learners. Now we are going to wind up the session. Tomorrow Mega Compact is there, so try to attend it. And coming Monday, okay, in the next session, vector calculus 4.